All right, let's talk about what goes wrong with machine learning, basically artificial intelligence applied to the real world. Because, there's some tremendous examples of things that are working right, like, self-driving cars is huge. A lot of the stuff that goes on with some of the examples I've shown you is tremendous stuff that's working right. And we've had some big successes, but there's also what we'd call artificial stupidity. Now, the first half of this lecture really comes from a book called You Look Like a Thing and I Love You by Janet Shane. She's an AI researcher down in Colorado. The book is a worthwhile and entertaining read. It is not tremendously technical, but it points out what happens when you take AI and apply it to real-world problems. Now, most of our ideas of general-purpose artificial intelligence are what we see in the movies. The Terminator decides for some reason to kill off humanity. It's malicious. It decides to take over. I don't think that this is very realistic. I don't think that artificial intelligence have a malicious intent. They don't have an anything intent. They just have training on what their data set is. There's no emotion, no care, and no desire. So why would they want to take over the world? It's kind of silly. What they do have is that if you have a bad data set or one that doesn't actually capture what you're trying to tend, you have garbage in and garbage out in the world. And I'm going to give you some examples of that. Image recognition in cars is a huge problem in which they have spent a tremendous amount. Tesla, a while ago, a person took the autopilot, which is designed for running on highways, and they turned it on while running on a city street. And a truck pulled out in front of them. This is kind of a sad story, because the Tesla autopilot misidentified the side of a truck as an overhead sign and drove right into it. It thought it could go underneath it. Maybe thought is excessive there. In any case, it made the decision to continue without even braking, because obviously this big square thing that was across the road had to be a sign. It wasn't a vehicle on the road. And it killed the driver. Now, the problem was that at that point in time, this was version 1, and this is a couple of years ago now, the Tesla autopilot was only trained for running on roads, and its concept of a truck was either the front of a truck, the back of a truck, or a truck passing you, or you passing a truck. There was no concept of the side of a truck. There was no training on the side of a truck. There was no training for the possibility of something pulling out in front of you like that. Because on a highway, you don't see them pull out in front. You see them merge or cross. But they certainly don't pull out in front and stop. So its training set was basically wrong. Now, a while back, quite a few years ago, I was driving in New York on a particularly wet and rainy, cold day, and there was a cliff there, and a fairly large rock came out of the cliff and went skittering across the road. Probably 5 or 10 tons. 3 feet in diameter size rock. Maybe 20 tons. I stomped on the brake, I slid some, but I could compensate. I have some experience driving, as do a lot of us, and I managed to make it around the rock without hitting the rock, without hitting the oncoming traffic. Now, with Google Waymo, their self-driving system, you've got to ask the question, have they trained it on any big rocks falling on roads? And on average, okay, and Tesla's is the poorest example of self-driving, it is better than a human being. You are better off to have it do the driving than you to do the driving. And Waymo's is a lot better, but there are still things it's not going to be trained on. And it's going to make a bunch of wacky mistakes that it will do things that people will go, what? That is so weird. One of those other concepts that you've got to put in this category of it's so weird is the whole thing of the computer is always right. And basically, if you're filling out a form with a person's name in it, and this applies to lots of stuff besides artificial intelligence, if you're doing user interface design and you put something with somebody's name, they will, requirements, and people will specify things that, a person's last name is more than 2 characters, that they have to have a middle initial. These things are not true. I have a friend whose last name is just the letter G. Now, he's Chinese, and G is spelled differently and translated differently, but one of the possible translations for G is just a single capital letter G. And he cannot fill out forms because they seem to think that last names have to have at least 2 letters. And this is also true for addresses, that, there is a much wider variety of addresses than you might possibly think, including in the United States. For instance, UPS, I know, is notorious for succeeding in delivering packages like the one that was addressed to the house just down the street from the lighthouse on St. Simon's Island. Now, that's not a regular address, but it seems to work. But try putting that address into a form. The house just down the street from the lighthouse. And yes, a human being can understand it, but can a computer allow it? And then turn this up to the level of an artificial intelligence. What does it mean to be just down the street from the lighthouse? Another example I would give you of this sort of a thing is one of communications failure. And this one, again, comes from Google self-driving cars. They had one of their self-driving cars being actively used by one of their employees that is blind. I mean, this is a big convenience factor, and a really, old people and blind people and people that can't drive, people that have disabilities, being able to have a self-driving car is a huge factor in their lives. So he was testing it one day on his way to work, and he happened to be hungry. And so he told the car, and the car has a voice interface, so you've got to wonder if it's the voice interface or something else, but he told the car to drive through the drive-thru at this upcoming restaurant. The car figured this out, turned, entered the drive-thru, drove through it, got back on the road, and continued on to work. It didn't stop. Now, there's a certain amount of this that is communications failure. As in, the car has to have the concept of go through the drive-thru, which is part of this. It did that. But it also has to have the concept of, in the drive-thru, stop so the person can get food. There is a purpose behind this that wasn't specified by just go through the drive-thru. And it also has to have the interface capabilities of knowing you stop at the sign where you make the order and you stop at the sign where you pick up the food, which are 2 more pieces that are missing from this. Now, legitimately, the guy went to the Google self-driving folks and said, this is what it did. And they all had a good laugh, and somebody went and got him some breakfast. And, they corrected this. But how many more of these special circumstances do you have to do? And the thing that I would point out in a general big picture scenario from self-driving, and this applies to all of artificial intelligence, is when we use artificial intelligence to do some task, yes, we get the computer to program the computer. But we haven't gotten rid of the necessity of testing. We've just moved the testing from testing the software down to testing the results from the software. And you've got to test it and find out if it's doing what you want. And that move from testing code to testing results is a big move, but you still have to test it. Google has been testing for years with their self-driving cars before they've gotten to the point where they actually have a working system. Now, you can feed some results into an artificial intelligence and get some good results out. One of these examples here I'd like to make is for ice cream flavors. They took 1,600 flavors of ice cream and went, let's come up with some new flavors that would be really good. And these are good flavors and bad flavors of ice cream, and they fed them into a program to learn what good flavors are and then generate some new ones. I don't know if you think pumpkin trash break would be a good idea, or peanut butter slime, or strawberry cream disease, but these are recommendations from the computer as to what human beings would actually like as flavors. And I'm not too keen on any of those, to tell you the truth. I think they're a little bit odd. I want to talk about some examples that will explain the oddness of the ice cream in a better way. Okay? You can teach a neural network to walk. And in this particular case, they basically said, here are the parts of a person, assemble them in some fashion, and make it walk. And you and I have the concept that you go from A to B by walking, and this is the way that you put it together. Now, the computer doesn't have that concept. It just has that you go from A to B with these parts and you assemble it. So when it assembled the thing to walk, it just simply said, oh, well, I'll just make it really tall and I'll make it fall over, and it arrives at B. And in a certain sort of way, this makes some kind of sense. In another way, it's very odd because, it doesn't match with how things are actually put together. There is no big creature like this that is at least a mammal, although there are plants that use this technique to spread. And they basically go tall, fall over with their seeds at the top, and arrive at a new location. So there are things that do this, but there are no animals that do it this way. And it certainly doesn't meet our criteria of walking. We have a certain concept involved in what constitutes a walk that this doesn't meet. So programming an artificial intelligence, a machine learning system, you have to put in constraints. And I have another example of this that I'd like to run. And basically what he's done is he's finally gotten a thing that does what we consider walking to go across an obstacle course. Now, along the way, he had some extra constraints he had to plug in. For instance, you can't make the legs so big that you overcome the obstacle course by taking 0 steps, falling down, and arriving at the end. So you have to constrain the length of the legs. You have to constrain how much they can bend. You have to say that, yes, the legs need to be on the bottom. Yes, you need to use the legs to support you. Yes, you need to use the legs so that you stay upright. That, rolling over on your head and using the legs to flick back upright really isn't a walk either. And you've got to have all these constraints, or the AI will simply take the path of least resistance. That's, as a principle, probably the biggest one. Whatever it comes up with is a local minimum. That's all it is. It's a path of least resistance. The second one is the AI has no understanding of what you're trying to solve. It simply has an input set of training data and an output result it's after. And probably it has some sort of gradient that if it takes 1 step, that's not as good as taking 2 steps. So the farther it gets, the better the results. Now, this means, in a practical sense, that there's no understanding, there's no goal, there's no emotion. It's just a mathematical model that says the farther you get with this mathematical model, the better. That's it. So it's got nothing that's going to help it in any particular thing other than some constraints and solving the problem. The danger of AI is not that it is too smart. It's that it's not smart enough. Okay? I mean, legitimately, most artificial intelligence convolutional neural networks have the intelligence of about an earthworm. So you may be able to train it to separate cats and dogs, or to recognize faces, or to do some other task. Okay, we've talked about picking pickles, which basically is see the size of the pickle and separate them by size and are they straight. But this limited data set isn't a model of the entire world. It's just a very limited data set that allows you to train it to do a particular thing, recognize a particular thing, and anything that is outside of that data set, any changes in the data set, can produce bizarre, weird results. And no, AIs are probably not going to steal your job. What it's going to do is it's going to end up transforming your job in a bizarre way, mostly. Now, you may be more productive when you get done. Maybe it pre-filters the data. Maybe it does things that you couldn't otherwise do. But getting it to go beyond that to something like self-driving is really, really hard. I added up across the car companies what I see that they're spending on developing self-driving, and it's something on the order of $100 billion being invested in the task of self-driving. This is not a trivial investment. Now, it's worth it, okay, or they wouldn't do it. But even so, this is a very, very large amount of money being invested to get one fairly complex problem solved in AI. And it's not a trivial problem, but it is still not there yet. I mean, they have not gotten to the point of training this to where it is a general purpose solution. I want to talk a little bit about racism and things that also happened. Google went out and decided to use AI to pre-filter resumes. They liked the result until they found out that their pre-filter on resumes determined that based upon their past hiring practices, since most of their employees are male, that you should just automatically reject all female resumes. That they are not good candidates. And here's one about predictive policing, and that they are racist, because they were racist in the past, therefore if you predict what's going to go on in the future, you get the same results. They found the same sort of thing with software that determines sentencing and who goes on parole and who doesn't. Basically that it has racism baked in. Now think about the fact that the computer's always right, and suddenly that racism baked in becomes even more insidious. It becomes more damaging. Because instead of being able to correct it, what it does is it puts it into the computer program on a permanent basis. So there's a link to this article. It's worth reading. Now, one of those other applications that we see is the algorithm. This is the thing behind Google's recommendations, behind Facebook's feeds, behind Twitter's tweets. And this is a recommendation engine. Basically, the goal of the recommendation engine is to get you to respond, get you to keep your eyeballs attached to the page, get you to continue to watch more videos for YouTube, get you to tweet in response. Microsoft tried one of these things with a chatbot. Within 24 hours, the chatbot had turned radical right, saying obnoxious things, I mean vile things that are really nasty about people. But guess what? When you do that, you get lots of tweets back. You get lots of messages back. And in Brazil, they had this kind of a recommendation engine. They still do. And that recommendation engine started out with this person who basically was trying to learn how to play a guitar. Then he saw some videos about the person that was giving the guitar lesson and their political attitudes. The political attitudes got reinforced the more he clicked, the more he saw, the more radicalized he is, and the entire country followed down this rabbit hole of YouTube into being basically a radical right country. Whether it's true or not has nothing to do with it. The voices are authoritative because they're there right there, and you're listening to them. And you're giving them power by giving them your eyeballs. And it changed the entire politics of an entire country. And to some degree that's happening in the United States, but not as much. But even so, what it is doing is the more polarizing the video, the more polarizing the message, the more polarizing the news piece that is or is not true, okay, the more people will pay attention to it. And the more attention you can get, the more eyeballs you get. The more eyeballs you get, the more you can charge for advertising. So the money, if you follow the money, the algorithm drives increased attention and increased sales. And when you do that, you make a lot of money. And that's basically what's going on inside YouTube and Facebook news feeds and Twitter and other social media. And it's being driven by an algorithm that has no moral cognition, whether this is good or bad or good for the country or you or I. What it is good for is the bottom line of companies like Google and Facebook. And it is good for attracting attention without any analysis of whether or not it's true. And this is the algorithm. Now, if you're a YouTube person, you post on YouTube, and you want to increase your chances of getting people to subscribe, because the more subscribers you have, the more your videos are recommended, the more your videos are recommended by the algorithm, the more subscribers you get, the more money you make. Their recommendations, if you read their guidelines, is that whatever your videos are, I mean, if you're going to teach about black holes, you should include a relative permanent or personal information about your life so that you can build an emotional attachment to your viewers. So if you're going to talk about black holes, talk also about how you stubbed your toe and how much it hurt and how you jumped up and down and looked really funny at the same time while you're talking about black holes. Now, this other stuff has nothing to do with black holes, but you see it all the time in influencers in YouTube. Is the more personal, the more of a relationship they can build, the more subscribers they get. So this process of personalizing is driving their sales. And the more sales they get, the more views they get, the better they do and the more money they make. So this is also part of the entire process, is turning things that should be information into basically weird little personal relationship stories. Sitcoms. I mean, they're fun. Doesn't mean they're good or they're right. But this is intertwined with the entire process that YouTube uses for its artificial intelligence. This is intertwined with Google's, you do a search on Google and it is going to be reflected in this process. And believe me, if you go out into Google right now, go out into YouTube, and whether or not you believe the Earth is flat, I mean, there's plenty of places where you can see out here in the West, you just look around and you can see that the Earth is not flat. You don't have to go to space to do it. You don't have to see a picture from orbit to tell that it's a sphere. You don't have to look like a couple nights ago at the shadow of the Earth on the moon to see it's a sphere, and you could clearly see that if you looked up. But you go and say, flat Earth, and you search for it. And you will find people that are authoritative that say that the Earth is flat. And after you have done that, you will get more videos in your front page that talk about flat earthers. And you click on a few more of them, and pretty soon you'll get a lot. And you will get tremendous confirmation bias that the Earth is flat. And you can do this for any subject you want to today on YouTube, whether it is true, right, left, middle, anywhere. And you will not get information, you will get confirmation. That's all you will get out of it. And that is because of the algorithm and how it works and how it responds to the fact that you clicked on that video and you watched all of it. And the more radical and bizarre the video is, the more likely you are to go, wow, that is weird. I'm going to have to watch to the end of it. That is really weird. I'm going to watch the whole thing. It's bizarre. Okay? But the fact that you went and saw it once bizarre means that now you have influenced what you're going to see in the future, and you are going to get more things that are just like it. And if you watch enough of them, pretty soon you'll believe most anything. It doesn't matter. So that radicalization is happening here. It's happening everywhere in the free world that is allowing people to use these kind of tools. And that's most of the world today. So these AI algorithms are having a tremendous impact, not just on some stuff, but on politics and information and how we transmit that in our society at large. So the good and the bad, they have no intent. They just are, and they are trained to do some particular thing that they're being optimized for. I'm going to leave you with that. Next time is our last lecture. When we do talk about it, I will be talking a little bit about the final. If you want to take the final, it is probably legitimately optional for everybody in this class. You've all done really well in the class through the semester, and it's not been the easiest semester. But we will be talking about the final. I believe, and I will send you individual emails on this subject, that for everybody, the final will not change your letter grade in the semester. You have already gotten enough points, and the final is small enough that you can neither go up nor down a letter grade. So it is optional, which means I would much rather see you take your time and invest it in all of your other classes and see if there is some place that you can change a grade. Now, as you go through college, and I know some of you are starting, some of you are way through, changing a letter grade on a final is very rare. Less than 1% of students in colleges will manage to do that in classes. Our class is not that big. It just isn't mathematically possible in this class. So I will tell you that up front right now. I'm going to finish the grading here in the next couple days and have all this stuff out to you. And when I do, you can evaluate for yourself, and I will have a final available. It will be a writing assignment for a paper. It's not going to be some sort of a test. It is to write a paper. So if you want to, it's up to you. I will read it with glee and be glad to see what you write. But no matter what grade I give you, it will not change your semester grade at this point in this class. I've already mathematically checked. All right, with that, one more lecture after this, and we are off to the final. The final will be due on Friday at midnight, the 11th, and I will have that out to you Monday for sure, maybe sooner. All right, catch you later.